that being said, I would like to introduce our final speakers here. Last but certainly not least, Vitor, Vivek, and Audrey from our very own Amazon team will be presenting on knowledge graph-powered AI assistant, speeding up maintenance and troubleshooting. So.
Perfect, thank you. So yes, glad to be here with you today. So we are with the team. My name is Audrey. I'm leading the knowledge experience and technology team in Amazon Army. I'll come back to the context later. And today I'm on the call with Vivek, sitting next to me, senior data scientist, specialized in natural language processing, and Vitor, who will also walk us through the solution, so applied scientist and with a focus on neurosymbolic AI. So for today's presentation, let me go to the next slide here. We will walk us through 4 different steps. The first is who are our customer base, whom are we serving? They are internal customers. I'll explain what are the main challenges are. Then Vitor will walk you through how we combine different technologies to develop our assistant, which we actually started before the availability of Bedrock. So we'll explain how this helps us extend the number of use cases. Which solutions are we using behind the scene, and then walk you through several examples that we serve for our customer base. So in terms of whom are our customers, so our organization, it calls Reliability Maintenance Engineering. So what the organization does is basically focused on maintaining and repairing equipment in our warehouses. So in the automotive industry, you may also think about production lines as well. But basically, as John actually mentioned earlier in the webinar, we started actually pretty small. So with the first customer group, whom are our planners. And so what they do is that they schedule maintenance activity, and they also need to ensure that the necessary parts and tools are available for maintenance tasks. Now, our planners also need to work hand in hand to coordinate with our second customer group, which was the second we onboarded into the tool, who are our field technicians. In other industry, you also call them service technicians. And their role is to ensure the maintenance and the repair of equipment. So it can be anything from inspections, regular inspection, or intervening when there is sometimes breakdowns, troubleshooting what is happening, and so on. What's common with the automotive, I would say, and we'll come back to that a bit later, is that the issues that our technicians can face can be of very different nature. They can be mechanical, electrical, systems related. We have one driver, though, that we kept in the development of the solution from start to end, is that everyone needs to adhere to the safety standard while they are performing the task. And so that driver also drove the way we designed the architecture for the solution. Now, what is the challenge that we face? So when we surveyed our internal customer, a common pain point that we observe is that it's quite difficult to locate both accurate and comprehensive instruction for tasks they need to complete. So here I'm not talking about SOP, who are readily available, but more equipment manuals, references, specific troubleshooting for software, for instance. And the opportunity is big for us because we had 1 out of 3 colleagues that expressed that it's difficult or extremely difficult to find information for different reasons, of course. One of which is, you can see on the right of the slide, is that we have actually a lot of information available, but for some reason, different reasons, it takes them a very high effort to reach that information, and that information is critical to complete the task. So that's our area of focus for the virtual assistant. And that challenge, why is important for us to solve? Because, of course, as you may imagine, the longer you need to take the information to intervene, then it can also significantly impact the repair time and then the overall, of course, service to the final Amazon customers. So our main objective with this project and other solutions that the team develop is to really accelerate the delivery of information that people need to accomplish goals. How does it look in terms of user story? I will not go through all the steps, but basically it can happen that you're facing a situation where you find manuals that are not precise enough for what you're trying to do, for instance, or you may struggle to get the latest version of third-party technologies that you work with, things like this. Just last week, for instance, we had the technician reaching out and say, hey, I'm looking for this, but the manual is a bit vague. Do I need to use this type of ruler or this type, and how should the belt travel? So these are very domain-specific questions, which again will be driving the architecture we chose to opt for. So with that, I'll just give you an example to explain the opportunity. So that's what we can see here on the slides. We have millions of searches every year in different systems. What you actually see is a low estimate. So if you can imagine that if search, when it goes well, takes 2.5 minutes, the number of productive hours just spent on search. the opportunity is even bigger, because so there are searches, and then you have searches that are successful. You find what you were looking for. There are some searches that are not, where people abandon, and that abandonment cost is actually the highest. Why? Because then people reach out to another colleague who will also search, or worse, they can recreate documents that already exist. So that's the challenge we are trying to tackle here. Really focus on the retrieval so that they have a better experience as well, and we also have a faster time to value. So before entering the details, how did we do this? So we have approached in different steps, and Mike mentioned it at the very beginning. One key for us was to actually focus more on the data foundations. So we went first for a centralized repository for manual standards and so on. We combined it with governance element as well, in terms of, okay, how to title the data, metadata management, things like this, to make sure we have a sound foundation. And then we combined it with the development of AI-enabled tools, such as the one we will present today. So our focus, again, very important, was definitely data integration and discoverability for two benefits. The first one is that we want to, as I mentioned, fasten access to specific manual and resources, because you will see it later in the presentation, but the type of questions people have require a high precision and high reliability. And the second one, which for us is an added benefit, but not negligible, is not only we want to accelerate information finding, but also fault finding, right? When you need to troubleshoot and you have a breakdown, we need to make sure that the fault is found quickly. And I was saying that 1 out of 3 people find it difficult initially when we surveyed people. What can happen is that, unfortunately, if you don't find guidance, it may be tempted to go for trial and errors, which may have other consequences, right? So that's what we want to avoid, making sure that people have access to all the information they need on the topic. So that's what you can see on the reuse part of the slide, so that then they don't have to lose time trying to search multiple times. So I also added an example on the slide, but for the use case, one of the use cases we covered, we went from several minutes for simple query to just under 3 seconds to get them to the specific information they needed. So that's our goal. And with that, I will hand over to Vitor to share more about how did we then build that solution to achieve this goal. The floor is yours, Vitor.
Thanks, Audrey. So in the context of maintenance engineering, retrieving very specific informations and getting answers that rely on multiple sources are very common among our customers, such as the example that we can see on the left part of the screen. So to be able to traverse those multiple sources and retrieve the required amount of information and actually the associated information to the answer to formulate a complete answer, we opt to use a graph-based RAG approach over a purely vector-based approach. And that's for a couple of reasons. So the first, vector-based RAGs, they are proven to be very good at accessing very specific and direct types of information. The information is contained within the chunks. And to do that, they rely on the semantic similarity between the question or the context and the specific chunk to be retrieved. But given the context of multiple sources and very complex hops of question and answering that we need in our domain, the graph shows a better capability. So for example, in the case a customer is looking for a specific equipment, it's very important to give them also all parts associated to this equipment. Unless the customer specify each single part associated with that equipment, a poorly RAG-based approach, vector-based RAG, wouldn't be able to extract this similarity and the actual full context about that specific equipment. But a RAG-based system, given the relationship between the equipment and parts, we can retrieve such information. Also, the graph-based approach allows us to better integrate both scenarios where we have transactional information with structured data and unstructured data from texts, manuals, and multiple other sources of documents that we rely in our context. So leveraging the graph connectivity, we're able to construct better context and retrieve better information to then formulate the answer for our customers. This tree 360 view over the equipments, over the parts, over the question of the user are fundamental in our industry, because this will help them to speed up troubleshooting scenarios, among others. Please, Audrey. One of the many features that we have in our cognitive assistant is the capability to transform natural language questions into queries to retrieve those informations. And for that, we leverage a neurosymbolic system that we built. So relating the symbolic part of the system, we have the question comprehension, where we get the user's question, we extract the relevant entities, we align those entities and argument the user's question based on our knowledge base, and then we identify the intention of the user. This intention identification is paramount to evaluate the proper tool that we're going to call, given that we are using agentic framework. So in this specific case, we are leveraging the COE graph Q&A. COE stands for a correction of error, which is a document that it's very common in Amazon that people write to explain and troubleshoot a specific challenge they face in the field. So in that specific scenario, for the COE graph Q&A, we first do the prompt fitting, where we get the extracted entities, the augmented entities, and the context relevant to those we fit into our prompt. We then rely, powered by generative AI, we generate this query, and then we retrieve the information that the query could give us based on what we have in our knowledge graph. After that, we post-process, and once again, we leverage this capability, the conversational capability of generative models, the foundation models, to formulate a natural language answer for our customer. So this is one of the many use cases that we have within our cognitive assistant. So this is our reference architecture. First, our customers, they always use the conversational interface that we provide them. So we build this front end, and this front end is able to communicate with the backend part of our system. Our cognitive agent, it relies on a Lambda, on a full serverless architecture to communicate with our data sources and our intelligence layer, where we rely on Bedrock, for example, as one of the many AI systems that we use to generate queries and do other types of tasks. Our data sources, they are very comprehensive. We use Neptune, we use DynamoDB, and we use relational databases as well to gather the information needed for our cognitive agents. And we extract information through ETL pipelines across different organizations and domain within Amazon to build our own source of information. For that, we consume those multiple sources, S3 buckets, among many other sources of information. And with that, I'll leave to Vivek to present a bit about our use cases.
Thanks, Vitor. So, everyone. So Audrey and Vitor spoke about the kind of use cases we are covering and also the architecture. So while building this system, we interacted a lot with our customers, trying to understand their pain points, and then going back to the drawing board to understand the kind of data which is available to us and how we can leverage that data to build a system which can answer questions that they have on a day-to-day basis in the field. So some of the data sources that you can see over here, and as Audrey was also mentioning, the data governance piece. So we pull data from those disparate systems. In most cases, they don't talk to each other. So we pull them together into our knowledge graph. and that applied a lot of transformations so that we could bring them all on the same level, because certain categories on system A would not be the same, would not have the same values for the same categories in system B. So we did all those transformations. To give you an example of the kind of data sources we have is starting with the site details and inventory level information, which contains information about the various fulfillment centers and other facilities that Amazon has, and the corresponding spare parts and other inventory level information which is contained for those sites. And then we map those information with the equipments which are operational on those sites, and then we map those with the user manuals for those equipments. This helps us answer questions like the parts associated with a particular equipment, or the min-max level of the parts which are needed for a particular site, who is the supplier, or what is the lead time, on those kind of questions. And then we add the information related to the work orders that the technicians perform on a day-to-day basis. Then this helps us provide additional information about the equipment, the technician who is going to perform those tasks, and the parts which would be needed for those, and the prior history of the work orders which have been performed on those equipments. So this information is available. Add policy information to that, then the technicians are able to understand, like, the policy guidance which is required to be followed for operating those equipments, or for repair work. Like, there are certain electrical equipments for which we would want an authorized or certified technician to perform the task, rather than just versus a mechanical technician. So those differences are considered in the policies. And then we have the correction of error information, which is also a collection of all the past incidents and learnings from those which may have happened on a particular work order, particular equipment. And then it provides that learning to the technicians to be careful about what may go wrong, or what not to do, or what to do. Those learnings are also applied. And then finally we add information from phone tool, which is basically the internal employee directory within Amazon. It helps them reach out to the counterparts in different sites. So for example, equipment A at site 1 may have an issue, then the same or similar equipment at site 2 may have had the issue. So those technicians can talk to each other. They can reach out to the planners, technicians, to get more information, or initiate transshipments for spare parts, which is a common case when one site has a surplus and other side needs it. So they can trigger those transfers quite easily. So while working on these use cases, we broadly classified them into these categories. And the first three categories we've already covered in the examples that I mentioned in the previous slide. In this particular, in the fourth category, which is more about data analytics, this is where we evolved from a static query to dynamic graph-based queries, which are built on the basis of the questions that the users ask. And so it may be like having some custom columns, or maybe certain properties like aggregate or sum of certain numeric values, so that they get required information. And then putting all of these together, for example, the spare parts information, then the equipment, the work order, the COE policy, and all this provides a as Vitor was mentioning, the 360-degree view of what they are going to work on. And the technicians are easily, able to do the decision making in a faster way, and it saves them a lot of time. This is the glimpse of the system that we have built. It's a web-based interface. So in the first picture, you can see it provides a step-by-step troubleshooting guidance on the user's question, and in the second one, it provides answers on the basis of the question. It's a simple tabular data, but internally we represent it in a different way. So we do all those transformations to make it available for the customers. And the overall value, I would say, goes beyond troubleshooting. So the primary task, which is entrusted to Quartz, which is our system's name, is to locate critical spare parts while automating the processes of contacting planners and for transshipments and all. But by streamlining the efforts involved in locating those documents and parts, we free up time for our technicians so that they can focus on process improvements and best practices, so that they have potential to be adopted across the network within Amazon.
And so takeaway for the project's learnings from us. So the first, and that relates to actually our roadmap for next steps also. So one of the things we want to, which was key for the success of the project, was to, as we mentioned, reinforce the governance around data and information. So data quality and management. So for that, we expanded our governance framework to include regular audits, for instance, on data review, cleaning mechanism to make sure that the information we share is of high integrity and accuracy. And so because we are thinking to go more on multimodal, as well as Mike was mentioning at the very beginning, by integrating such things such as sensor data, for instance, or a common use case is actually looking up parts by images, then we will also, our next step will be to actually expand this framework to provide more guidance about storing and managing that type of data that is more multimodal in nature, so that we can then expand to new use cases.
Paramount principle to our system is reliability and trustworthiness of the answer. So for that, to avoid situations such as information created by the LLMs without proper grounding, we implemented multiple layers of guardrails to protect and to avoid the hallucination effect of those generative systems. Even though we rely a lot on knowledge existing in our graph, those situations might happen. So we have multiple layers of guardrails to avoid to overcome those situations. Also, the interpretability and transparency of our questions are a fundamental aspect of our system, and we provide those by providing the sources of our information and grounding this answer into our sources, so the customers could access through our application. From as next steps, we're planning to deep dive more in those reasoning capabilities fundamental for neurosymbolic systems, where we're going to leverage these inference rules and all sorts of symbolic AI that could be explainable as well to our users, and also provide within this scope of multimodal capabilities, visual root cause analysis that will help our user to get a more interpretable answer from our system.
Last but not the least, from regularly engaging with customers, we know that not all users prefer conversational interfaces. Some prefer search engine interfaces, some prefer more elaborated, lengthy documents. So, or user guides, for example. So to make it more efficient, we need multiple interaction modes. And this is where we are going to head towards, to enable the user to choose what works best for them. So virtual assistant is not an end goal for us. It's one of the components of a broader intelligent cognitive system that supports maintenance engineering activities. With this, we come to the end of our presentation and open for question answer and pass it over to Lon.
Thank you, folks. Much appreciated. Let me go ahead and share my screen, and we can go ahead and hop into the Q&A. The poll for the presentation rating should be up. Please take a moment on the right-hand side of your WebEx to fill that out, please. I believe we have a question from the audience from Anchor. Audrey, do you see that one? If not, I could read that out.
Yes. What are the key parameters taken into consideration for comparison when picking up the GraphDB?
Well, this was a very debatable discussion we've had, and we wanted to make sure that the database that we choose is not just open in terms of the kind of data sources that we pull data from, but it also is versatile enough to support the kind of queries which customers are going to ask. So not just a simple RAG-based workflow, but so in terms of supporting storage of embeddings, but also in terms of analytics or different types of questions that we have. So we evaluated multiple databases and then came up with a final solution for that.
Great. Any other questions in the audience out there? If not, I have one for Vitor. Curious, Vitor, what happens when the virtual assistant encounters a question that it can't answer?
There are multiple scenarios where we can define cannot answer questions. So, and those are mostly identified on those multiple layers of guardrails that we have. So we have the scenarios where we have we consider inappropriate types of questions, where we have the mechanisms to identify those misbehavior intentions, and we avoid answering those. There are other scenarios where we identify that the answer is not related to the proper user question, or the answer is from multiple different sources, where those sources are not direct aligned with the intention of the question, of the user of the question, and we protect them through those multiple layers of guardrails. We have we basically in our system we use some levels of React for those who understand the architecture of agents. So we deep dive into the question, we retrieve context, and we think about those contexts. So then we can come up with a full answer for our users. So then through those multiple processes, we can protect our system to provide unsecure and unreliable questions. That's why we consider a reliable and trustworthy system.
Thank you. I believe we have a follow-up
Yes.
from Anchor. Anchor, would you like to come off mute?
Yeah, I wanted to speak during that. So just coming back to the original question. So in the answer you mentioned that you're anticipating something, that there will be certain subset of questions that the user would be asking, and based on that you are selecting DB. But like, could you help me? Like, I'm trying to figure out a solution there. That what exactly should I ask myself? Like, let's say 5 questions that would give me a ball path to one of the graph database, or if a graph database. So the if part is more clear to me, but one of the graph database is completely hazy for me at this stage.
So the question is about selecting the graph database and not the kind of questions the users will ask.
Yeah.
It's a bit of both, I think, Winkle, based on what you're saying. So there are two things, and then let us know if that answers your question. So in the choice, for instance, we definitely went for Neptune also for the analytics part of things. Is, as you know, is one of our other use cases. So the way we chose which use case to cover and also which of the architecture is that we develop also another science system that help us have an aggregate what's the trend in terms of search patterns, which one are successful, which are not, a bit like the slide at the beginning with the high effort, low satisfaction, and underserved, which is the critical. So
Satisfaction scores are the LLM evaluation scores or the
So
feedback, the user feedback?
this is separate actually, yes. Now that you bring user feedback, so we actually have three mechanisms to choose, okay, what type of question we will handle with the assistant. The first one is looking at the customer behavior. So that customer behavior for us, we do it in a data-driven way where we look at aggregate search. For instance, if you see a lot of, okay, what's the policy to handle this problem in this fulfillment center? That's a topic about policy. If
So
they
are you
ask,
also using the sentiment analysis with the original question before generating
no,
answer?
so
No,
we
okay.
are, that's another method that we are actually thinking to integrate to the assistant. So that's a very good one. So we do more traditional NLP on this, so where we classify those queries according to the topic, and then we look again at the success rate of the search or the effort, because you may have some searches where
Okay, so
people
you are
click,
using a
they go back and
classification
forth.
algorithm, one of the
So
classification
how we
algorithms for
so how we started is we started by looking into the search patterns from existing systems, and then we built a classic NLP model around this. And this is way before, like well,
Before we
not way
started the
before,
virtual
but
assistant,
before like the LLM thing became like a mainstream thing, if I can say that. So we started with a classic NLP model, and then we even built a system, like based on our interactions. Based on the user search pattern and based on our interactions with the customers, based on the feedback that we keep on getting from them, we added more question shapes and more classes to our model, and we even built a system that would generate questions based on popular question shapes, like how to do this, tell me this, show me this,
variants,
those kind of
basically.
yes, so those variants. And then based on the feedback that we continue to receive, then we transitioned those learnings into our current system, which is totally built on LLM, like around Bedrock and the LLM based solution. And now we've moved away from the classic NLP model.
And to your question, Lenkor, about high level, two type of question. Currently, two type of use case we have are related to either the content of documents, so more document understanding part, and Vitor can expand more on that if that is of interest. And then the analytics part of question, which is where we also really leverage Bedrock to again generate those queries that users say in natural language against the graph database. So that's another type of question that we get, like how many parts
I
here,
think
or
on
how
the
many
second
incidents
part,
in that.
I'm a little bit clear, but on the first part, I have questions. Like, what questions should I ask myself that this graph database would suit my requirement? And that is something like this is
So your
open.
question is basically how
Yeah.
how do we map those questions to the choice of database?
Yes, correct.
So basically, these are two different things for us.
Yeah.
One is the choice of database is
Performance,
more towards
scalability, all
yes,
those.
more towards those factors, as Audrey mentioned: performance, scalability, and then integration with our downstream system, well, yeah, upstream systems, I would say. And then in terms of querying capability, whether it will be able to we will be able to query the data in a format that we want to generate. So those kind of capabilities we've seen. For example, certain databases would require us to implement a cluster, like most of them have a cluster-based solution. So we wanted to have a cluster such that we have one write replica and two read replicas, for example, so that we have a robust system which can support in case of a disaster recovery kind of a scenario. So those things we would look into, we would take into consideration.
Okay.
And of course, the integration with Bedrock as well.
Yes, and integration with Bedrock, how easier it is to make it all built in a seamless manner.
Okay, and is there an
Ankur,
intelligent analytics solution as well? Like, if I understand this solution that you were mentioning, text to query, I see that as intelligent analytics, right? So is the system automatically nothing happens automatic? So is there a configuration mechanism so that enables the intelligent analytics, basically converting these requests into queries and then using it, or?
So it's more, I would say, domain driven. The kind of system we've built can be easily replicated for other domains, but right now we built it around the domain around maintenance engineering and troubleshooting guidance. So we've put it put the systems components accordingly. But yeah, we can definitely
the mechanism is replicable. The only difference I would say is the representation and modeling of the domain knowledge.
Yes, the architecture can be replicated, but underlying things are.
Yeah,
Okay, we have run out of time. With just 1 minute.